So look at question 5 from the stats test. So we're told the discrete random variable x takes the values 0, 1, 2 and 3 and has the following probability generating function. So we are told there that x takes values 0, 1, 2, 3. So if you think about your distribution, it would look like this. Don't worry about what the probabilities are necessarily. They're just P0, P1, P2 and P3. That's how we interpret what this is. Remember, the t is a dummy variable. The power of t tells you x. So here, t to the 0, t to the 1, t squared, t cubed. So if we think about these, if we've got x plus 2, that means the possible values that you get for your distribution of x have 2 added onto them. So x plus 2 can take the values 2, 3, 4 and 5. So you can see here our powers of t need to be changed to represent these values of x. So the probability generating function for x plus 2 is p0 t squared, because the probability of p0, chance of getting 2 was p0, plus p1 t cubed, plus p2 t to the 4, plus p3 t to the 5. Similar process for 3x. The x values are times by 3. So if we're doing g of 3x t, p0 plus p1 t cubed, because the x value has been times by 3, plus p2 t to the 6, plus p3 t to the 9. We do number 3, similar process. It's g of 3x plus 2. Well, here's 3x. We're just adding 2 onto each of the values of t. So this becomes t squared. This becomes t to the 5. This becomes t to the 8. And this becomes t to the 11. Find e of x in terms of this. So again, now for part B, first bit, we're using g of x t equals p0 plus p1 t plus p2 t squared p3 t cubed. So we're going back to using the original probability generating function. We know that e of x is g dash of x t, g dash of x with t replaced with 1. So g dash of x t, differentiating this, is p1 plus 2 pt p2 t plus 3 p3 t squared. Therefore g dash of x with 1 is p1 plus 2 p2 plus 3 p3, which is our e of x. So I've lost that there. Yep, so we just differentiated this, and then we've substituted in t equals 1 to get that. Hence prove. So the hence tells us we're going to need to use that. Hence prove g dash of 3x plus 1 is 3 of x plus 2. So we know g dash of 3x plus 2 t, differentiating this gives us 2p0 t plus 5p1 t to the 4 plus 8 p2 t to the 7 plus 11 p3 t to the 10. So g dash of 3x plus 2 to the 1 is just going to be 2p0 plus 5p1 plus 8p2 plus 11p3. So, what is 3e to the x plus 2? It's got to be the same as this, so let's just work towards that. Well, that's 3 lots of p1 plus 2p3 plus 3p3. plus the 2. So now we've got to work between the two. So looking at these two, how are they going to be the same? So you could rewrite this. Let's get this bit out from up here. So if we write 3p1 plus 2p3 plus 3p3 up here, that leaves us with, not much space, but that leaves us with 2p0 plus 2p1 plus 2p2 plus 2p3. So 2 lots of that. So hopefully you're starting to see there's a link here between the 2 and this 2 here. So what we know, which is probably what you wouldn't spot necessarily easily, is that we know by definition g of 1 is 1 if something's a probability generating function, i.e. the sum of all the probabilities is 1. That's what this is basically saying. If you go back to this table here, we know that these probabilities have to add up to 1. So when we put t of 1 in here, you're adding up all those probabilities, because t of 1 would be p0, p1, p2, p3 added together. So we know that this is p0 plus p1 plus p2 plus p3. Therefore 2, which double this, is going to be this. So, bringing that together, we can say our 3e of x plus 2 is 3 lots of p1 plus all of that, plus which is g dash of 3x plus 2 to 1. So we've proven it.